Hi all, welcome to another session of Biochem Tutor. In this session, I am going to discuss about a six-membered heterocycle, that is pyridine. In this session, I mainly include what is pyridine, where it is occurred, how it is isolated, what are the method of synthesis of pyridine, and last I am discussing their physical and chemical properties of pyridine. So coming to the first topic, that is what is pyridine. Pyridine is a six-membered heterocycle containing nitrogen as the heteroatom, and it has more resemblance to that of a benzene because it contains three double bonds and which participate in the delocalizations of the pi electron just like that of a benzene. Moreover, it contains nitrogen atom, and this nitrogen atom is having an unshared pair of an electron and which is not participating in the delocalizations. And its IUPAC name of pyridine is acene, and in pyridine there are three types of a hydrogen atom, that is second and sixth position hydrogen atom are termed as the alpha position, and third and fifth position in the pyridine hydrogen atom are termed as a beta, and fourth position are termed as the gamma hydrogen atom in the pyridine. So coming to the next topic, that is where pyridine is occurred and how it is isolated. Pyridine actually occur in the light oil fractions of the coal tar and in bone oil. So to isolate the pyridine from the light oil fractions of the coal tar, first the light oil fractions of the coal tar is agitated with dilute sulfuric acid. Then the pyridine and other bases present in the light oil fractions of the coal tar get converted into soluble sulfate. Then these sulfates are separated and then neutralized with the sodium hydroxide to liberate the bases, and then pyridine is recovered by fractional distillation. Next, I am discussing the synthesis of pyridine from acetylene. So when acetylene is mixed with hydrogen cyanide and then passed through a red hot tube, we are getting pyridine as the product. Coming to the physical properties of pyridine, pyridine is a colorless liquid and it is not having a favorable smell, that is it is having a pungent odor, and its boiling point is 115.4 degrees Celsius and it is soluble in water, and when it is miscible in water, the solution becomes basic in nature. Next we can discuss the chemical properties of pyridine. Before going to the chemical reactions of the pyridine, we can discuss the reactivity of the pyridine. So when we look the structure of benzene and pyridine, we found that one carbon-hydrogen bond in the benzene is replaced by a nitrogen atom with an unshared pair of an electron in pyridine. And moreover, this pyridine contains three double bonds and which help in the delocalizations of the pi electron, and thereby all ring carbon atom and nitrogen become sp2 hybridized and ring becomes cyclic and planar, and that become the aromaticity of the pyridine, just like that of a benzene. But the nitrogen atom present in the pyridine is again having an unshared pair of an electron which is not participating in the delocalizations of the pi electron. So this availability of the non-electron help in the further protonation, that is when it dissolves in water, it helps get attracted with hydrogen by this lone pair of electron present in the nitrogen. That makes the pyridine basic in nature. Moreover, when we compare the reactivity of pyridine with benzene, we found that pyridine is less reactive than that of the benzene. Again, when we look the basic character of pyridine with pyrrole, we found that pyridine is stronger base than that of the pyrrole. This is because pyridine is having a nitrogen atom and with an unshared pair of an electron. That means there is an availability of the lone electron which help in the protonation, further protonation. That is why pyridine become more basic. But in the case of a pyrrole, there are lone pair of electron present in the nitrogen atom, but which is helping in the delocalizations of the pi electron. That lone pair of electron is helping in the aromaticity. And further, lone pair of electron is not available for the protonation. That is why pyrrole is less basic than that of the pyridine. Again, when we compare the basic character of pyridine with an aliphatic tertiary amine, we found that pyridine is less basic than that of the aliphatic tertiary amine. Because in pyridine, the nitrogen atom is bonded to 2 sp2 carbon. But in the aliphatic tertiary amine, the nitrogen atom is bonded to an sp3 carbon. And when we look the pyridine, sp2 carbon become more electronegative. That That means it becomes more acidic in nature. But in aliphatic tertiary amine, nitrogen is bonded to sp3 carbon means sp3 carbon means it is less electronegative than that of the sp2. That is why pyridine is less basic when compared to the aliphatic tertiary amines. So the basic nature of pyridine is confirmed by the additions of any inorganic acid like HCl or HBr to pyridine. It results in the formations of an pyridinium salt. So when pyridine reacts with HCl, it results in the formations of an pyridinium chloride. Similarly, when any alkyl halide is treated with pyridine, it results in the formations of a quaternary salt. That is, when pyridine reacts with methyl iodide, it results in the formations of N-methyl pyridinium iodide as the salt. Next, we can discuss the reduction reactions of pyridine. That is, what happens when pyridine undergo catalytic hydrogenations. So, when pyridine is treated with hydrogen in the presence of nickel or palladium or platinum, we can get piperidine as the product. That is, all the carbon-carbon double bond get added with hydrogen. Similarly, the reduction can also be carried out with sodium in the presence of ethanol. Next, we can discuss the addition reactions of pyridine. Mainly, what will happen when pyridine undergo addition with halogen. So, when pyridine undergo addition with halogen, it results in the formations of a dihalate at room temperature itself without the presence of any catalyst. So, coming to the electrophilic substitution reactions of pyridine, we found that the pyridine is less reactive towards the electrophilic substitution reaction. Why? Because when we discuss any electrophilic substitution reaction like chlorination or sulfonation or nitration, we are carrying out each electrophilic substitution reaction in the presence of an acid. So, when pyridine react in the acid medium, easily it gets protonated, that is at the nitrogen atom. Because there is a lone pair of electron present in the nitrogen atom, so it gets protonated. That means a pyridinium ion is formed. And this pyridinium ion is less reactive than that of the pyridine. And therefore, it will deactivate the ring towards the attack of the electrophile. That is why pyridine is less reactive towards the electrophilic substitution reaction. But under drastic condition, if electrophilic substitution reaction is carried out to pyridine, mainly the electrophile will attack at the third and fifth position of the pyridine, that is mainly at the beta position of the pyridine. Coming to the nucleophilic substitution reaction, we found that pyridine is more active towards the nucleophilic substitution reaction. Why? Because when nucleophile is attacking the pyridine means nucleophile is already electron rich. So when it attacks the pyridine, there will be a formation of an intermediate, that is nitrogen become a negative charge, that is there is a formation of a pyridinium ion. And this pyridinium ion is highly resonance stabilized, and that this negative charge present in the nitrogen atom will be delocalized over the entire ring. And last step in the nucleophilic substitution reaction is the leaving of the better leaving group, and a nucleophile will be attached and there will be a recovery of the aromatic ring system. So when a nucleophile is attacking at the pyridine, mostly the nucleophile will attack at the second and the fourth position of the pyridine ring. Why? Because more resonating structure are obtained when nucleophile is attacking at the second and the fourth position. That is mainly at the alpha and the gamma position of the pyridine. So coming to the nucleophilic substitution reactions of the pyridine, we can discuss the aminations of the pyridine. That is, when pyridine is reacted with or treated with sodamide, we are getting 2-aminopyridine. That is, sodamide means amine act as a nucleophile, that is, it is having a strong basic character. And so when pyridine react with sodamide, we are getting the second position, that is an amino group will be attached to the pyridine. And this reaction is having a name termed as Chichi-Babin reaction. Coming to the next nucleophilic substitution reaction, that is the reaction with a Grignard reagent. This Grignard reagent acts as a better nucleophile. So when pyridine react with a Grignard reagent like benzyl magnesium chloride, we are getting a 4-benzyl pyridine as the product. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.